Morning, students. So, in the last class, we discussed about the Fourier series, Fourier transforms, Fourier series quotients A naught, A and B n, how to find out the Fourier series quotients A naught, A and B n, and uh, this convert this form into polar form and find out the magnitude and phase, etc. S naught equal to say square root of A n square plus B n square, or S n equals square root of A n square plus B n square, and phi n equal to tan inverse minus tan inverse dn by an, like that. Okay, so we discussed about all these things in the last class, and already we have done some problem also. Okay, we have done this problem, and finally we draw the magnitude in phase spectrums for the given problem. This is the problem. So what is this problem? This is the problem for the signal e power minus t, m of t equal to e power minus t. Okay, for the sum of equal to e power minus t during the interval 0 is less than t is less than 1. Okay, we'll find out the Fourier quotients a naught, a n, and b n. Okay, after writing this a naught, a n, and b n in frequency domain representation of m of t, a naught plus sigma n equal to n to infinity, n equal to 1 to infinity a n cos n omega naught t plus b n sin n omega naught t. Okay, so for our simplicity, it is converted into complex term, that is m of t equal to s naught plus sigma n equal to 1 to infinity s n cos n omega naught t minus phi n. Okay, so after finding this magnitude and phase, we'll draw the magnitude and phase spectrums. So this is amplitude or magnitude spectrum, and this is phase spectrum. Okay, phase angle versus omega, magnitude versus omega. Okay, magnitude versus omega, phase angle versus omega. These are the plots between amplitude and angular frequency, phase angle and angular frequency. Okay, now we'll go for the next problem. Draw the amplitude and phase spectrum for the signal m of t, which is as shown like this. This is like this. It is two signals here. We have two signals given here. It is varying from -1 to 1. From 0 to 1, it is 1 minus t. From -1 to 0, it is 1 plus t. M of t value is okay. So m of t equal to 1 plus t for -1 is less than t is less than 0, and it is equal to 1 minus t for 0 is less than t is less than 1. So how much will be the time period? That is from -1 to 1. -1 to 1, 1 unit, 0 to 1, 1 second. So 2 seconds. Total 2 seconds is the time period. T naught, fundamental time period. So f naught equal to reciprocal of this one, 1 by T naught, that is 1 by 2, it is equal to 0.5 Hz. 0.5 Hz is the frequency, fundamental frequency. And what is the angular frequency omega naught? That is 2 pi into f naught, that is 2 pi into 0.5, that is pi radians. Okay, omega naught angular frequency is pi radians. Okay, pi radians. Next, what is the arbitrary signal m of t? M of t equal to a naught plus sigma n equal to 1 to infinity a n cos n omega naught t plus b n sin n omega naught t. Okay, right. How to find out a naught value? A naught equal to 1 by t naught into integral t naught to t naught plus t naught m of t dt. What is m of t? Here we have two m of t's during these intervals. So we can write this -1 to 1 m of t, or -1 to 0 and 0 to 1. So -1 to 0 is 1 plus t dt, and 0 to 1 is 1 minus 2 dt, 1 minus t dt. So by simplify this integral 1 dt, that is t, plus integral t dt, t square by 2. Here also it is t square by 2. Okay, so by simply substituting these values, so that we will get a naught value is 1 by 2. Okay, a naught value is 1 by 2. Similarly, an value. What is the formula for finding an equal to 2 by t naught integral t naught to t naught plus t naught m of t into cos n omega naught t dt. What is omega naught? Pi radians. Okay, n pi, that is n pi cos n pi dt. It is -1 to 0, 1 plus t into cos n pi n omega naught t dt plus 0 to 1, 0 to 1, 1 minus t cos n omega naught t dt. Okay, so it is in the form of integral x cos ax dx is equal to 1 by a square into cos ax plus ax sin ax. Okay, so 1 by a square into cos ax plus ax sin ax. Okay, so it is cos n pi into t dt. Okay, so a value is 1 here. So a value is n pi. Okay, x value is 1. Okay, x value is t. Okay, t. So it is by expand this minus 1 to 0 cos n pi t dt plus minus 1 to 0 t cos n pi t dt plus integral 0 to 1 cos n pi t dt minus integral 0 to 1 t cos n pi t dt. So apply this formula 1 by a square into cos ax plus ax sin ax. Okay, cos ax plus ax sin ax. So we will write this as integral minus 1 to 1 cos n pi t into pt plus minus 1 to 0 t cos n pi t dt minus 0 to 1 t cos n pi t dt. Okay, so cos theta dt sin theta. So cos sin n pi t by n pi with limits minus 1 to plus 1 plus 1 by a square, that is n square pi square into cos n pi t plus n pi t naught into t a t ax into x dx, right, with the limits minus 1 to 0 as well as 0 to 1. So by simply substituting these values, so that we will get here cos n pi is minus 1 whole power n. Okay, and sin n pi is 0. Okay, so simply substituting these values in this above expression, so that an will become 2 by pi square n square into 1 minus 1 whole power n. Okay, 2 by pi square n square into 1 minus 1 whole power n. So it will become 2 by pi square n square into 2 if n value is 1. If n value is 1, it will become 2. So 2 into 2 by pi square n square. If it is 4, it is also same value. It is 6, it is also same. Like this. Now, odd values. For odd values, if it is 3, if it is 3, so it is 2. If it is 5, it is 2. If it is 7, if it is 9, it is 2. Like this. So for odd values of n is, that is n equal 1, 3, 5, 7, 9, like that, we will get an equal to 2 by pi square n square into 2. For even values of n, if it is even value 2, then it will become 0. If it is 4, it will become 0. If it is 6, it will become 0, like that. If it is even value, then an value will become 0. If it is odd value, then an value will become 2 by pi square n square into 2. So here the given signal is even signal. Even signal means it satisfies the condition its original signal equal to its mirror image. M of t is equated to m of minus t. Okay. So here even signal means m of t equal to m of minus t, right? So if the given signal is even, then it contains only cosine terms only. Cosine terms means an terms, an cos and omega naught. So an terms are cosine terms, bn terms are sine terms. So here sine terms will become 0, right? So if the given signal is an even signal, then its sine terms will become 0. It contains only cosine terms, right? That's why bn will become 0. So that m of t is equal to a naught, that is 1 by 2 plus an 4 by pi square n square into cos n pi plus cos 3 pi by only odd values. We will take odd values. Cos 3 pi by t by 9 plus cos 5 by t by 25 plus cos 7 pi by t by 49, like that. Okay, so convert this into polar form. So m of t equal to s naught plus sigma n equal to 1 to infinity s n cos n omega naught t minus pi n, where s naught is a naught equal to 1 by 2. Sn is square root of n square plus bn square, but here there is no bn term here, only an term is there. Okay, 2 by, that is 4 by pi square n square. So 4 by pi square n square whole square plus 0, right? So an square plus bn square, that is bn square value is 0. So that it will become, mod, mod sn equal to mod sn equal to 4 by pi square n square, and pi n equal to minus tan inverse bn by an, but there is no bn term. So tan inverse bn is 0 by an, that is tan inverse 0, that is 0. Pi n is 0. So here phi n is 0. Since phi n is 0, there is no phase spectrum for this problem. Only we have the amplitude or magnitude spectrum for Sn mod Sn equal 4 by phi n whole square. So n omega naught mod Sn. Substitute these values so that you will get the magnitude spectrum or amplitude spectrum like this. Okay. So this is the problem. If the given problem is an even signal or even function, then there is no sine term in this problem. Only it can consists of only cosine terms only. It consists only cosine terms, not sine terms. If it is even signal, then only this condition satisfies. Okay. Next, coming to the next problem. Draw the amplitude spectrum, phase spectrum of the signal, time domain signal m of t. It is represented as, it is nothing but half wave rectified wave. Half wave rectified wave. This is the output of half wave rectifier. Okay, it is having the amplitude at some extents. 0 to pi, it has some signal. Similarly, 2 pi to 3 pi, it has some signal. Similarly, 4 pi to 5 pi, like that. It has the amplitude em. Okay, so it is varying from 0 to pi and 2 pi. So during the half of the cycle, which is full cycle, during the positive half cycle, it exists. During the negative half cycle, it does not exist. It means that its value is 0. During the negative half cycle, that is from pi to 2 pi, its value is 0. From 0 to pi, that is positive half cycle, its value is some value. Okay, so here T naught is, we have to note the T naught, that is fundamental time period, that is 2 pi, 0 to pi, 0 to 2 pi, and f naught equal to 1 by 2 pi, and omega naught equal to 2 pi f naught, 2 pi into 1 by 2 pi, that is 1 radian. Okay, so this sines are half sine side waveform is em sin omega t. Okay, so em is the amplitude of this sinusoidal wave. So em sin omega t for 0 is less than t is less than pi, and is 0 from pi to 2 pi. Okay, so we have to find out a naught, an, and bn values. A naught equal to 1 by t naught in integral t naught to t naught plus t naught m of t dt. Okay, so what are the limits? 0 to pi. 0 to pi em sin omega t plus pi to 2 pi, it is 0. So this entire thing will become 0. So integral 0 to pi sin omega t, em sin, extract em outside, em by 2 pi into sin t, integral sin t, that is cos t. Cos t with limits minus cos t, with limit 0 pi. So by simply substituting this 0 and pi values in this expression, so that we will get a naught equal to em by 2 pi. Em by 2. Next, coming to the an value. How to find out an? An equal to 2 by t naught in integral t naught to t naught plus t naught m of t cos n omega naught t dt, right? N omega naught t dt. So 2 by pi, t naught is pi. So 0 to pi em sin t into cos n t dt plus pi to 2 pi t 0 value. Okay, so that it will become em by pi integral 0 to pi sin t into cos n t dt. So it is in the form of integral sin ax cos bx dx. Okay, integral sin ax cos bx dx formula is minus cos a minus b into x by 2 into a minus b plus cos a plus b into x by 2 into a plus b, right? So convert this given problem in this formula, write this problem in this formula, so that it will become em by 2 pi into minus of cos 1 minus t into t by 1 minus n plus cos 1 plus t into t by 1 plus n with the limits 0 and pi. By substituting these values and 0 and pi in these values, so that we will get em by pi into 1 minus minus 1 whole power n plus 1 by 1 minus n square. Similarly, here we'll substitute the n values, even values and odd values. If n values are even, then it will become em by pi into 2 em by pi into 1 minus n square. If n values are odd, then it will become 0. It is not even function. For even functions only, we have the condition. What is that condition? For even functions or even signals, we have only cosine terms. For even signals, the problem will contain only cosine terms. Sine terms will become zero for even signals only. So this is this problem is not even signal, so that we have to calculate Bn value also. So Bn equal to 2 by T naught into integral T naught to T naught m of t into sin n omega naught to dt. Okay, omega naught value is 1, so sin n t dt. M of t is em sin t. So em sin t 0 to 5 em sin t sin n t dt. Okay, into plus integral pi to 2 pi t 0, so it will become 0. So that m by pi into integral 0 to pi sin t into sin n t dt. It is also in the same formula. It is also in the form of the formula sin ax sin bx dx. Integral sin ax sin bx dx is equal to sin a minus b into x by 2 into a minus b plus sin a plus b into x by 2 into a plus b. So substitute the problem in this problem, so that it will become em by pi into minus of sin 1 minus n into t by 2 into 1 minus n plus sin 1 plus n into t by 2 into 1 plus n 0. So it will become 0, so that the bn term will become 0 here. So m of t equal to m by t minus 2em cos an term only 2em cos n pi by pi into 1 minus n square. So its polar form is m of t equal to s naught plus sigma n equal to 1 to infinity Sn into cos n omega naught t minus pi n, where s naught equal to a naught equal to em by pi and Sn equal to square root of n square plus bn square. So here bn value is 0, that's why square root of n square only 2em by pi into 1 minus n square whole square. Okay, it will become mod Sn equal to 2em by pi into 1 minus n square for even values of n only. For odd values of n, it is 0. Okay, and phi n equal to minus tan inverse dn by n, but dn is 0, so that it will become 0. So here also phi n become 0, phi n value will become 0. So there is no phase spectrum, only we have the amplitude spectrum. Okay, so take different values for n values, omega values and Sn values. So draw the graph between omega and mod Sn, so that it will become like this: omega naught 2, omega naught 3, omega naught 4, omega naught 5, omega naught 6, like this. And these are the mod Sn terms, right? So we have only amplitude spectrum, not phase spectrum. Okay, for this problem also we get only the amplitude spectrum. Okay, right. Next, coming to the next problem. Okay, this is here we are taking different problems for we are taking one problem for one model. Okay, so different problems. Have a glance and observe it clean, observe it carefully. Okay, draw the amplitude and phase spectrum for the rectangular pulse train m of t, which is as shown like this. This is the rectangular pulse train. Okay, this is the rectangular pulse train. See, m of t is given like this. So its time period is from here to here. From here to here, it is minus tau by 2 to plus tau by 2, means its value is tau. Okay, its value is tau. Already here is also given. So, but T naught is this is tau and this value, this and this value. Okay, T naught. Okay, okay. We will solve this problem. Okay, see what is the time period. We are assuming that here the time period is 2 pi, 2 pi seconds, 2 pi seconds. So fundamental time, fundamental frequency is 1 by 2 pi. So angular frequency is now 2 pi into f naught, that is 1 radians. Okay, so what can be mathematically expressed as m of t equal to a for minus tau by 2 is less than t is less than plus tau by 2, and is 0 for from here to here. So here to here means it is 0 for tau by t is less than t is less than t naught, t naught, well, t naught minus tau. This is tau. T naught minus tau. T naught minus tau. Okay. So next, what is the next step? We have to calculate the Fourier coefficients A naught, An, and Bn values. A naught equal 1 by T naught to integral T naught to T naught plus T naught m of t dt, right? So here the limits are minus tau by 2 to tau by 2, its value is a, and plus tau by 2 to T naught plus tau, its value is 0. So that only we have this, we have to consider this term only 1 by T naught into A. A is constant, so A into integral T, that is AT. AT with limits minus tau by 2 to plus tau by 2. So A by T naught into tau by 2 minus of minus tau by 2, that is this is tau. So A tau by T naught, right? So A naught value is A tau by T naught. And An equal to 2 by T naught into integral T naught to T naught plus T naught m of t cos n omega naught t dt, right? So by simply substituting, we'll get An value is 2a by pi n into sin n pi by t in tau naught into n pi by t naught into tau. That is An value. So it is an even signal. It is even signal. It is both sides of the quadrants, first quadrant and second quadrant. So and it is a mirror image. So first the image in the first quadrant will appear as a mirror image of that one in the second quadrant. So okay, it is an even function, so there is no Bn value. So m of equal to a naught, that is a tau by t naught plus sigma n equal to 1 to infinity a n cos n omega naught t. Okay, so 2a by pi n into cos n pi by t naught into tau into cos 2 pi n by t naught into t. So since Bn is 0, there is no amplitude spectrum. There is no phase spectrum. Here it will be converted into compact form, that is polar form. So m of t equal to s naught plus sigma n equal to 1 to infinity sin cos n omega naught minus pi n. Okay, so cos n omega naught minus pi n. So s naught equal to a naught equal to 8 over t naught, and mod Sn is the square root of n square plus n square. Here Bn value is 0, so that we have only n square value. So 2a by n pi into sin n pi by t naught into tau whole square plus 0, or it is equal to 2a by n pi sin n pi by t naught into tau, and pi n value is 0 because Bn value is 0. That's why pi n value is 0. So the amplitude spectrum is plotted for a rectangular pulse with the duty cycle 20%. Here we first of all we will draw the amplitude spectrum for the rectangular pulse with the duty cycle 20%. So here the formula is duty cycle. What is the formula for duty cycle? Duty cycle equal to T on by T on plus T off. So duty cycle is 20% is equal to T on is tau, and T on plus T off is T naught. Okay, so tau equal to T naught by 5 r, T naught will become 5 tau. Okay, T naught will become 5 tau. Substitute 5 tau at the place of T naught. So 8 tau by 5 tau S naught is equal to 8 over 5 tau, that is a by 5. And similarly Sn equal to 2a by n pi sin n pi by 5 tau, okay, into tau, or it will become sin n pi by 5. So the amplitude spectrum for rectangular pulse train with 20% duty cycle is as follows. That is like this one. This is the amplitude spectrum of the rectangular pulse train with 20% duty cycle. Okay, so this is the amplitude spectrum. There is no phase spectrum for this one. Why? Because Bn value is 0. Okay. So this is about the trigonometric form of the Fourier series, and some problems related to trigonometric form of the Fourier series. So what we have done here, we have to calculate the trigonometric Fourier series coefficients. Those are a naught, an, and bn by a in the formulas. Okay. So after that, these three formulas including arbitrary form m of t. Okay, for our simplicity, it can be converted into its polar form, that is s of t. Okay, here we will find out the magnitude and phase spectrum. Magnitude is Sn, mod Sn equals square root of n square plus bn square and phi n equal to minus tan inverse of bn by an. After that, we have to plot the amplitude and phase spectrums of the given problem. So amplitude spectrum is drawn between magnitude versus frequency. Similarly, phase spectrum is drawn between phase angle versus frequency. So this is about the today's class. With this, I am concluding the today's class. Tomorrow we will see the exponential form of the Fourier series.